For this part, we cover subchapter 5.1c, one-to-one function, 5.1d, sketch a graph of a function, 5.1e, domain and range of function. One-to-one function. A function for which every element of the range corresponds to exactly one element of the domain is known as one-to-one function. This is one-to-one function since every element of the range corresponds to exactly one element of the domain. As you can see, the arrow from -3 to -11, 0 to -2, 1 to 1, 2 to 4. Here, every element of range corresponds to exactly one element of the domain. This is function g are not one-to-one since every element of the range do not correspond to exactly one element of the domain. As you can see, 0 and 1 is mapped to 4. There are two methods to determine whether a function is one-to-one. The first one is graphical method, which is horizontal line test. The horizontal line test is used to determine if a function is one-to-one by draw horizontal line on the graph, and then if any horizontal line drawn intersect the graph of a function cuts only one point, then the function is one-to-one. The second method is algebraic method. To prove the function is one-to-one, we must show fx1 equals to fx2 implies that x1 is equal to x2. We start from fx1 equals to fx2 until we get x1 equals to x2. Example 2. Use the horizontal line test to determine whether each of the following function is one-to-one function. Let's say we have equation A, fx equals to x multiply x minus 2. This is actually a quadratic function. This is since x squared is positive, then the graph should be smiley graph with x-intercept at 0 and 2. Okay, to test whether this is one-to-one function, we use horizontal line test. So we draw a horizontal line test by drawing, let's say, line y is equal to k. As we notice, the horizontal line y is equal to k intersect the graph at 2 points. So therefore, f is not one-to-one function. Now, for question B, we have a function fx equals to x cubed minus 1. So this is a cubic function. X with x cubed is positive, so we draw from positive side, and it has x-intercept 1 and y-intercept -1. So this is the graph of x cubed minus 1. And then to determine whether this graph is one-to-one or not, so we use horizontal line test. We draw line y is equal to k, and we notice that horizontal line y equals to k intersect the graph at 1 point. So therefore, f is a one-to-one function. Now let's look at example 3. By using the algebraic method, determine whether f is one-to-one function. We have question A, fx equals to x plus 3. To use algebraic method, we start with fx1 equals to fx2. And then we substitute, for fx1, we substitute x1 into x on fx. For fx2, we substitute x2 into x on fx. So then it will give 2x1 plus 3 equals to 2x2 plus 3. And then we bring 3 on the left hand side to the right hand side. And then we get 2x1 equals to 2x2 plus 3 minus 3. So finally we get 2x1 equals to 2x2. Since 3 minus 3 is become 0. Then we divide both sides by 2. Then we get x1 is equal to x2. Since fx1 equals to fx2 implies x1 is equals to x2. So then this function is one-to-one function. Now for question B, we have fx equals to x squared plus 2x minus 5. Okay, so first if fx1 equals to fx2, then we substitute for fx1, we substitute x1 into x on fx, and for fx2, we substitute x2 into x on fx. Then it will give x1 square plus 2x1 minus 5 on the left hand side, and then equals to x2 square for plus 2x2 minus 5 on the right hand side. And then we bring negative 5 to the on the left hand side to the right hand side, and it will give x1 square plus 2x1 equals to x2 square plus 2x2 minus 5 plus 5. So then minus 5 plus 5 is become 0. And then it will get x1 square plus 2x1 equals to x2 square plus 2x2. And then after that, we do completing the square on the left hand side and on the right hand side. And it will get x1 plus 1 square minus 1 on the left hand side, and then equal x2 plus 1 square minus 1 on the right hand side. So we have to complete the square lah. And then after that, negative 1 we can cancel out since it's become negative 1 plus 1. So then we have x1 plus 1 square equals to x2 plus 1 square. And then to eliminate square, we square root both sides, and we get x1 plus 1 equals to plus minus x2 plus 1. Since it's square root, so then it will give plus minus. So since we have plus minus, we can split into two values of x. So the first one, x1 plus 1 equals to x2 plus 1. Or the second one, x1 plus 1 equals to negative x2 plus 1. So the first one, we get x1 equals to x2. Or the second one is x1 equals to negative x2 minus 2. So we have two values of x. So then fx1 equals to fx2 does not implies x1 equals to x2. So therefore f is not one-to-one function. Next, we continue with 5.1d sketching graph of a function. We may consider some clues in sketching the graph of a function. The first one, know basic shape of the graph. The second one is determine the x or y intercept if any, and then vertex if any, and then vertical or horizontal asymptote if any, symmetry of the graph, and finally the domain and range. Basic shape of a graph. Now first let's look at for constant function y is equal to k. Actually y is a constant function y equals k. We draw a horizontal line. Let's say first, to draw a graph, we must draw x-axis and y-axis. And then after that, to draw y equals to k, y equals to k is a horizontal line, so and it will show like this. Okay, for example, we want to draw y equals to 5. So then y equals to 5 is a positive, so means that it's above on x-axis. So then it will show like this. This is a graph of y equals to 5. The third function is quadratic function. The expression of quadratic function if f(x) equals to ax squared plus bx plus c, where vertex hk found by completing the square, f(x) equals to a multiply x minus h squared plus k, or using the formula h equals to negative b over 2a. In general, we have two types of graph quadratic function. The first one is open up, which is familiar with smiley graph. And then the second one is open down. It's familiar with sour graph. And then we have vertex HK. Okay. HK for smiley graph is actually a minimum point, and HK for sour graph is maximum point. Let's look at example. We have a function f(x) equals to x squared minus 4x plus 3. Since a equals to 1, b equals to 4, and c equals to 3. So a is more than 0. So then it's open up. We draw smiley graph. And then we find a vertex by using formula h equals to negative b over 2a. So then it will get negative 4 over 2 multiplied by 1, which is equals to 2. So we get h equals to 2. Then to find k, we substitute into fx. So k is fx is k, then h is x lah. So jadi we substitute k equals to 2 square minus 4, 2 plus 3, we get k equals to negative 1. So finally we get hk, the vertex is 2, negative 1. So to draw a graph, we draw a smiley graph with hk 2, negative 1. So the graph we show like this. Let's look at for second example. We have a function f(x) equals to negative multiply x minus 1 square plus 2. We notice that a is less than 0, so it's open down. So we draw a sour graph, and then since this is function it's in the form of completed square, so we know that vertex is hk. So the h is 1 and the k is 2. So vertex hk is 1, 2. And then we draw sour graph with vertex 1, 2. So the graph is represent like this. Now let's move to fourth function, which is a cubic function. The expression for cubic function is fx equals to ax cubed plus bx squared plus cx plus d. Let's try to sketch graph fx equals to x cubed plus 5. Since x cubed is positive, so we draw from a positive side, x positive. So then 5 is a y-intercept, so the graph will show like this. Okay, and then let's try to sketch fx equals to x squared multiply 3 minus x. If we expand, so then it's become 3x squared minus x cubed. So x cubed is negative, so we draw from negative side. So starting from left hand side, and then we find x intercept, we get x0 and x3. So it graph will show like this. Now let's move to another function, which is called as third function. The expression for third function is fx equals to third ax plus b, where ax plus b is more or equal to 0. The shape is based on the value of a. In general, we have four types of third function graph. The first one is a positive, and then third is positive, and then a positive but third is negative, and then a is negative but third is positive, and then a is negative but the third is negative. So we have four types in general. So the first one, let's say we want to draw fx equals to third x minus 2. So ax plus b more or equal to 0. So then x minus 2 more or equal to 0, and we get x more or equal to 2. This is the domain for fx. And then the third function is draw like cerun bukit. So then since x is positive, so the puncak is positive lah, is moving up. So then starting with 2 x2, so then the graph it will show like this. Starting with x2 is moving up lah, is bukit. And then let's say we want to draw fx equals to third 1 minus x. So since 1 minus x is more than 0, so then it will get x less or equal to 1. So starting with 1 but to the left hand side, because it's x less or equal to 1. So it's moving left side lah. So the graph will show like this. So this is third function. Now let's move to f reciprocal function. We have fx equals to a over bx plus c. Reciprocal function has horizontal asymptote y is equal to 0, which is x-axis. Horizontal asymptote y equals to 0 or x-axis. Vertical asymptote is x equals to negative c over b. When bx plus c equals to 0, f is undefined. So let's say we have a function y equals to 1 over x minus 1. So the horizontal asymptote is y equals to 0, which is x-axis. And then we find vertical asymptote x equals to negative c over b. We get x equals to 1. So vertical asymptote is x equals to 1. Asymptote means we cannot touch or we cannot cross the boundary. So means that the graph is red curve. So it's on right hand side and on left hand side. So if the x is positive, so it start with the above is start from positive, and the left hand side is on the below. Okay, so then we find y-intercept, we get -1. When x equals to 0, y equals to -1. And then we want to draw for y equals to -1 over x minus 1. Horizontal asymptote is y equals to 0, which is x equals to x-axis. And then we find vertical asymptote, we get x equals to 1. So then, since x is negative, so it starts above 1 from the left hand side, and the below 1 is on the right hand side. So it will give like this. So this is the graph of -1 over x minus 1. So then we find at y-intercept, we get y equals to 1. Now let's move to G, absolute value function. Fx equals to a absolute x minus h plus k. If a more than 0, the graph is open up in the shape of V shape. So this is a V-shaped graph with vertex 1, 2. If a less than 0, the graph is open down in the shape of inverted V. So this is inverted V graph with vertex is 2, 3. So the first graph is Fx equals to absolute x minus 1 plus 2, and second graph is Fx equals to negative absolute x minus 2 plus 3. So it's represent vertex here, absolute x minus h plus k. So a is 1. Then let's move to piecewise function. A function that is defined by two or more functions for different part of its domain is called a piecewise function. We have, let's say, Fx equals to negative x squared for x less than 0, x plus 5 for x more or equal to 0. So we have two different functions, two different functions with different part of its domain lah. X less than 0 and x more than 0 is called as domain, the value of x, including for its function. So we draw the two functions on the same axis. Okay, so negative x squared we draw for x less than 0. X less than 0 means on the left hand side, side of y-axis. And then the right hand side, y-axis is for x plus 5. So we draw x plus 5. So 5, we draw open close circle on 5. Since x more or equal to 0 is starting with x more or equal to 0, so then 5 is include. So then close 5 to the right, we draw linear is moving up. And then for negative x squared, the domain is x less than 0. So we draw open circle for 0. And then the graph negative x squared will give like this. So this is called as piecewise function. Now let's look at for example 4. Sketch the graph of the following function. The question A, Fx equals to x squared minus 9, Fx equals to sud x plus 5, and C, Fx equals to absolute 2x minus 5, and D, Fx equals to 1 over x minus 2. Now let's look at for solution question A, Fx equals to x squared minus 9. So this is quadratic function with a is more than 0, which is open up and it's familiar with smiley graph. And then vertex here, since this is in the form of complicated square, so then x is 0. We read from x squared minus 9, x is 0, and h is 0 and k is negative 9. So we have a tag 0, negative 9. So we draw a smiley crown with a tag 0, negative 9. So and then x-intercept is 3 and negative 3. For question B, we have fx equals to surd x plus 5. This is surd function. So x plus 5 is more or equal to 0. So then we get x more or equal to negative 5, which is, this is the domain for this function. So it starts with negative 5. Since it's more or equal, so it's to the right hand side. So then it starts with x negative 5 and to the right hand side. So surd function we draw like bukit, naik bukit. So it starts with x negative 5 to the right. So this is a graph of fx equals to surd x plus 5. And then we move to question C, fx equals to absolute at 2x minus 5. This is absolute value function. So since a is positive, a is more than 0, the graph is open up in the V shape. So the vertex is 5 over 2. 5 over 2, 0. Vertex is HK, 5 over 2, 0. So we draw V shape with vertex 5 over 2, 0. And then we find y-intercept, we get 5. Y is equal to 5 as y-intercept. And then we move to question D, fx equals to 1 over x minus 2. So this is reciprocal function. So horizontal asymptote is y equal to 0 and vertical asymptote is x equals to 2. We get x vertical asymptote from x equals to negative c over b. So then we get x equals to 2. So x-axis is the horizontal asymptote and x equals to 2 is vertical line, x equals to 2 is vertical asymptote. And then x is positive, so the above one is start on the right hand side. So and the below one is on the left hand side. So the graph, it will start with right hand side above and the left hand side is below. So this is graph of fx equals to 1 over x minus 2. Domain and range. Given fx equals to y, domain is the set of the values of x in which f is defined. Range is the set of all possible values of as x varies throughout the domain. Two methods to find domain and range is by using graphical or algebraic method. Method 1, by using graphical method. By graphically, x-axis represent the domain while y-axis represent the range. By using algebraic method, domain is the possible value of x for a function to be defined. Not in the domain are values of x where f is undefined, such as division by 0, negative values under a square root, and log of 0 and negative values. For example, to find finding domain, for fx equals to 2 over x minus 3, since the denominator cannot be 0, so then x minus 3 does not equal to 0, which it will give x does not equal to 3. So therefore, the domain is negative infinity 3 union 3 infinity. Means that the domain here, the values of x is all real values, all real numbers except for 3. For fx equals to surd x minus 2, so this is surd function. So means that the inner surd should be more or equal to 0. So then x minus 2 more than or equal to 0. So which implies x more or equal to 2. So the domain here is x more or equal to 2, or interval form is close to infinity. And then for fx equals to ln x minus 3, this is log function, logarithm function. For example, we have log a. So a is supposed more than 0. So then x minus 3 supposed more than 0, which implies x more than 3. So the domain here is x more than 3 or open 3 infinity in interval form. Finding range. For y is equal to fx, let's say we have fx equals to 1 over x. So let y equals to 1 over x. So then, since x does not equal to 0, the denominator cannot be 0. So then, x does not equal to 0. So the domain is negative infinity 0, union 0, infinity. The range is found by expressing x equals to gy and observe the possible value of y. So let's say x equals to 1 over y. So since y cannot be 0, so then the range is negative infinity 0, union 0, infinity. For example, let's look at for example 4. Sketch the graph of the following function and range and find its domain and range. For question A, we have fx equals to 2 minus 2x, B, fx equals to x minus 2 square minus 9, and C, fx equals to negative x cubed plus 8, and D, fx equals to negative 1 over 2x minus 5. Let's look at equation A. Fx equals to 2 minus 2x. This is linear function. So, since the m is less than 0, which is m equals to negative 2, so it's moving down. And y-intercept is 2. So, we draw the linear line moving down, and y-intercept is 2. So this is the graph of fx equals to 2 minus 2x. And then we observe from this graph, the domain is from negative infinity to infinity. It can be expand on the left hand side or on the right hand side. So then the domain is negative infinity, infinity. And since it's also can be expand negative infinity, range is also negative infinity, infinity. Since the range is the set of possible value of fx as x varies throughout the domain. Since the domain is negative infinity, infinity, so the range is also negative infinity, infinity. Now let's look at for solution question B. Fx equals to x minus 2 square minus 9. So to sketch this graph, so this is quadratic function. So this is in the form of completing the square. So since a is more than 0, so it's open up. So we draw smiley graph with vertex is 2, negative 9. We read from completing the square form. Okay, we draw smiley graph with vertex 2, negative 9, and then we find y-intercept is negative 5. So the y-intercept is negative 5. So then we read the domain and range from the graph. So since it can expand on the left hand side and the right hand side, so the domain is negative infinity, infinity. But the range we see from the below to the top, from yang paling bawah kepada yang paling atas. So yang paling bawah is negative 9, which is include, so it will get a range negative 9 include 2, since it can be expand right and left. So then it's also, it can bring expand to the above. So then domain is negative infinity, infinity. So and the range is close negative 9, infinity. Next, look at for question C. We have fx equals to negative x cubed plus 9. So this is cubic function with x cubed is negative. So it start from left hand side, x negative, and then the y-intercept is 8. So the graph, it will be like this. And then we read domain. We find domain and range by graphical. And then we observe the domain is it can expand on the left hand side and right hand side. So then the domain is negative infinity. And then the range is from below to the top. So below is also can expand. Top is also can be expand. So then the range, the domain is negative infinity, and the range also negative infinity. Now let's look at for question D, f(x) equals to negative 1 over 2x minus 5. So this is reciprocal function with horizontal asymptote is y equals to 0, which is x-axis, and then vertical asymptote is 5 over 2. So then we draw vertical asymptote and horizontal asymptote. Then since the x is negative, so it start with on the left hand on the left hand side above, and the right hand side is below. So the curve will give like this, and the y-intercept is 1 over 5. We notice that the domain, since it can be expand on the left hand side and the right hand side, but we cannot cross or touch 5 over 2. So the domain is supposed negative infinity, 5 over 2 union 5 over 2 infinity. And we observe the range from below to the top. So below is can be expand, and above it also can be expand to the positive y, positive infinity. But we cannot touch the x-axis. The x-axis is y equals to 0. So the range is negative infinity 0, 0, infinity, union 0, infinity. So this is finding domain and range. So this is the end of lecture 1. So that's all for this part. Thank you. Bye.